Welcome to Interface Studies. My name is Saleh. For nearly 40 years, the global digital experience has been governed by a single monolithic paradigm. We can call it the Xerox consensus. It was crystallized at Xerox PARC in the 1970s with the Alto and Star systems and subsequently popularized by the Apple Macintosh in 1984 and Microsoft Windows in 1995. It went through many iterations and changes. Conceptually, though, it stayed the same. This paradigm relied on two interlocking metaphors: the hierarchical file system and their WIMP interface: windows, icons, menus, and pointers. It started with desktop operating systems and moved into the web and mobile phones. The original paradigm was designed to bridge a specific historical gap. It was created for a workforce transitioning from physical paper to digital screens. To make the computer intelligible to a mid-century office worker, the interface mimicked their physical reality. Data lives in documents or files, which are placed inside folders or directories, which are stored in filing cabinets. These are disks. These elements are manipulated on a desktop using overlapping windows that simulate sheets of paper shuffling on cluttered desk. Most of the concepts that we live in today were not exactly intentioned to be how they are used today. But throughout the history, it all came together due to many reasons. And it was all brilliantly summarized in Ted Nelson's talk, "There's too much to say, and it goes in all directions." Now, while this model was brilliantly successful in onboarding humanity to personal computing, it has created a cognitive wall. By forcing users to act as filing clerks, manually naming, tagging, and placing blocks of data into hierarchical storage containers, we have prioritized the computer's storage needs over the human brain's associative nature. We have accepted the file not as a technical convenience, but as a fundamental truth of information. Now, in our mind, we do not store the memory of a childhood birthday party in C users memory 1990 events social. Instead, the human memory is associative. A scent of vanilla might trigger a memory of a cake, which triggers a memory of a specific person, which triggers an emotion. Access is immediate, contextual, and nonlinear. This friction between the computer's hierarchical storage model and the human's associative cognitive model creates a permanent tax on our attention, a cognitive load, if you will, spent managing the machine rather than doing the work. And in the late 1970s, one system attempted to erase this distinction entirely. In 1978, IBM released a mini-computer that was radically different from anything that had come before it. The System 38 was not designed to process data. It was designed to abstract the physical reality of the computer away from the user. It was an enterprise machine, but its architecture, the single-level store, or SLS, offers one of the earliest and most profound examples of an associative human-computer interaction philosophies. Now, in a conventional operating system, like Unix or DOS, the user is painfully aware of the difference between memory and storage. If you write a document in RAM and pull the plug, the document is gone. Now, a lot of the modern operating systems have different techniques to avoid this, but they weren't there. And it's still, as I said, fundamentally an engineering hack. Back in the day, to prevent all these problems, the user must perform a ritual save. This action takes data from the volatile workspace and inscribes it onto the permanent disk. The System 38 abolished this completely. It treated all storage, RAM and disk, as a single continuous address space. It used a mix of software and hardware to handle this memory management issue. It was all in one. Persistence was a property of the system, not an action of the user. And because system handles storage, the user interface of the System 38 and its operating system, or the Control Program Facility, CPF, did not revolve around files in the traditional sense. Instead, it revolved around objects. Everything was a typed object: a program object, a user profile object, or a database file object. The OS understood what these things were. A user didn't navigate a directory tree. They managed a library of objects. The interface was a green screen on a terminal. It relied on a command language that was rigorously consistent. Every command followed a verb-noun structure. While the System 38 is often dismissed as a dinosaur due to its text-based interface, its interaction philosophy was arguably more advanced than the graphical systems that replaced it. In a modern Windows or Mac environment, a user might see a file called invoice.dat and not know which application opens it. On the System 38, the system knew exactly what the object was and how to present it. That system failed to revolutionize consumer computing because it was enormously expensive and complex. The overhead of managing that single-level store required powerful hardware. It did survive, however, as the IBM AS400, or what is now called IBM I, powering the back end of global finance and logistics. Complexity in the architecture can yield simplicity in the interaction. By taking on the boundary of memory management, the machine frees the user to focus on the data itself. Another example that I talked about in my previous video about the history of graphical user interfaces is the Canon Cat. At its core, the Canon Cat was about textual streams. If IBM tried to solve the file problem from the server room, Jeff Raskin, the creator of Canon Cat, tried to solve it from a writer's desk. Raskin believed that the mouse was insufficient and that the windows were a distraction. He left Apple to build this anti-Mac machine, which ended up being the Canon Cat. It's a machine that embodied his principles of the humane interface. That was in 1987. The core critique of standard computing was that it forced users to fragment their attention. To write a letter, you opened a word processor. To calculate a budget, you opened a spreadsheet. Each open action broke a certain flow in the user's mind. The Canon Cat had no applications. It had no folders. And it had no operating system visible to the user. When you turned on the cat, you saw a cursor on a blank screen. This was not a document. It was a unified stream of text. The user's entire digital life, letters, notes, code, lists, existed in this single, long, continuous scroll. To perform a calculation, for example, the user didn't open a calculator app. They simply typed the math into the text stream and pressed the command key. The system evaluated the text in place and inserted the answer. Word processing and calculation were not modes the machine entered. They were operations performed on the universal data type. The challenge, of course, is if we had a 10,000-word text stream. What kind of navigation are we going to have? How do you find a specific letter you wrote 3 months ago without scrolling for hours? Raskin's solution here was the leap key, and it was located below the space bar where the thumbs rest. The two leap keys, leap forward and leap backward, were the primary navigation mechanism. To move the cursor, the user held down the leap key and typed the target text. To jump to the word apple, the user held leap and typed APP. The cursor immediately jumped to the first instance of that pattern. This is what Raskin called the quasi-mode. A standard mode, like caps lock, for example, on our keyboard, is dangerous because the user can forget that they're in it, leading to potential errors. A quasi-mode is maintained only through physical muscular tension, which is holding the key. The moment the user releases the key, the mode ends. This eliminates mode errors because the user's body is consistently aware of the state. Now, the Canon Cat was a commercial failure. It was marketed poorly as a word processor rather than a revolutionary way of computing. The world was already charmed with the visual dazzle of the Macintosh. However, lots of the ideas in Cat are now in the developer's world. The editor Vim uses similar keyboard-driven navigation. Spotlight on macOS and the Command K menus in modern web apps are direct spiritual successors to the Leap key, mechanisms that allow users to jump contexts instantly via text. The Cat proved that text is a universal interface, a concept that is returning with a vengeance in the age of the AI and its chat interface. In the early 1990s, Apple attempted to create a new class of device, the PDAs, or the personal digital assistants. The Newton Message Pad in 1993 is often remembered for its handwriting recognition quirks. But its true innovation lay in its file system, or rather the lack of it. The Newton OS was built around the concept of soups. In a desktop operating system, data belongs to an application. A .xls file belongs to Excel. If a calendar app wants to see that data, it needs to import it or use a complex API. On the Newton, there were no files. Data was stored in a system-wide database of objects called soups. And in that system, a contact created in the address book didn't live in the address book. It lived in the name soup. This meant that any application could access it. A third-party project management app could query the name soup and display contacts without needing permission or an API integration. This data liquidity allowed the Newton to implement an assistive interface that predates modern AI assistants like Siri by 2 decades. For example, the interface relied on gestures. A user could write "lunch with Bob tomorrow," and the assistive button would interpret this intent. It would query the name soup for Bob, the calendar soup for tomorrow, and creates a linked event. This reversed the standard computing interaction. Instead of open app, create data, the Newton model was create data, system finds app. The user didn't need to know which app handled lunches. They just needed to know they wanted lunch. The Newton failed due to its hardware immaturity. The processors were too slow for accurate handwriting recognition. The screens were low contrast. However, the soup concept is the holy grail of modern mobile OS design. We see echoes of it in iOS's Spotlight or Android's Intents. But modern systems have actually regressed in some ways, locking the data back into the app sandboxes for security reasons. The Newton remains a vision of a world where data is a shared resource, not a hoarded asset. Now, moving from this file system problem, and while IBM, Canon, and Apple focused on the structure of data, others focused on the visualization of it. Oberon was an operating system, a language, and a user interface all in one. But the true innovation of Oberon was active text. In a standard GUI, buttons are distinct from the text. In Oberon, any word could be a command. The user could middle-click it to execute that command. This meant that users could build their own interfaces simply by typing text. A menu wasn't a special system object. It was just a text file with a list of commands. After the Canon Cat, Jeff Raskin continued his work with a project called Archy, or the Humane Environment. Archy took the infinite stream of the cat and added a spatial dimension to it, which was the zoomable user interface. I made a distinct video about zoomable user interfaces before. In the infinite plane of Archy, instead of windows opening and closing, Archy presented an infinite 2D plane. The user's data existed on this plane. To open a document, you didn't double-click an icon. You simply zoomed in on it. As you zoomed in, the representation changed from a speck to a headline to a full text. To close it, you zoomed out. The core concept of that interface was the reliance on spatial memory, remembering where things are. Archie removed the concept of launching an app. Tools were omnipresent. If you wanted to edit an image, you zoomed into the image. The image editing commands became available. The app was just a set of capabilities attached to a data type, not a walled garden you had to enter. Now, unfortunately, Archie was never completed, but its influence is visible in infinite canvas apps today. And again, there's some regression. The app sandbox resisted every single change that was attempting to get rid of it. And we have all these capabilities in separate apps, even if they utilized some of the concepts that were originally in Archie. Now, for decades, the concepts of the System 38 or the Canon Cat and the Newton, they were all admired by academics but ignored by the market. They failed because they required too much from the user, which is learning a new paradigm after all that investment that went into the traditional paradigm that we live in, and the hardware requirements were quite high. The 2020s, however, have brought this shift. The emergence of generative AI and vector search has suddenly made the associative interface not just possible, but inevitable. We're witnessing the resurrection of these retro-futurist ideas, powered by engines that finally understand human intent. One of the interesting and technical foundations of this modern renaissance is the vector database. In a vector database, information is stored as embeddings, which is mathematical representations of meaning in a high-dimensional space. In this space, the vector for dog is mathematically close to the vector of puppy. The vector for contract is close to agreement, sign, and legal. And this technology might make folders obsolete. A user does not need to store a file in a specific location and find it. They simply need to query the system with a concept. For example, a command like "show me the legal documents about the plumbing project" will retrieve the correct files even if the word legal never appears in them, because the system here understands the semantic relationship between the query and the content. And developers are now experimenting with what is called vector virtual file systems, vector VFS, where the OS itself indexes every file vectorially. This turns the entire hard drive into a soup. The file location becomes an implementation detail, irrelevant to the user. Now that was technical. There was also some interface work that is happening and that is interesting. Several modern startups are explicitly attempting to build the post-file world using these AI technologies. They might not work and they might have their own problems, but they are direct descendants of this Canon Cat concept or the Newton. For example, with mem.ai, which is a note-taking application, but in that single concept, it's asking us to forget about organization, which is something we see in a lot of these AI-supported services. Limitless, granola, and many others. There's also hardware. In 2024, two high-profile devices attempted to bring the post-app interface to hardware. There was the Rabbit R1 and the Humane AI Pin. Both were spectacular failures, or at least for the Humane AI Pin. The Rabbit R1 is still trying. These devices promised to free users from the app trap. Instead of opening Uber, selecting a destination, and confirming, the user would simply speak to an AI. Get me a ride home. The Rabbit uses what it's calling a large action model to operate underlying services, which are in fact cloud-based mobile operating systems. Now, regardless of the technical details, the R1 features a small screen and a scroll wheel. It's a completely different interaction model. The Humane Pin relied on voice and laser projections into their user's hand. And while the R1, as I said, hasn't failed yet, but the failure of the pen was that it underestimated the efficiency of the graphical user interface for confirmation. Speaking "order a pizza" is easy, but verifying toppings, price, and delivery time via voice is tedious. The GUI allows scanning information in parallel. Voice forces serial processing. The most radical development in modern human-computer interaction is probably generative UI. This concept, championed by researchers at Google and some other companies, but probably Google has the most clear implementation of it, moves beyond generating text to generating the application or the interface. We have Google Disco, which is a consumer-facing experiment that demonstrates the ability to generate UI from text and taps. And there's A2UI, which is a developer-facing protocol or a standard that allows other agents to do exactly the same thing. And this is something that we'll likely see a lot more of in browsers. Some browsers, like Arc Search from the browser company, effectively unbrowses the web for the user, so that the user doesn't have to spend lots of time going through different pages. It assembles information from different resources and put them in one. The generative user interface is a bit more interactive, but as I said, it's likely to be in browsers, where we spend most of our time. And the browser war is something else that I made another video about. To a certain degree, we are currently circling back to the ideals of the 70s and the 80s, armed with the processing power to finally realize them. The file was a necessary evil for the scarce computing era, a mechanism to manage limited storage and limited processing power. The future interface is one of associative continuity, a single, searchable stream of information where the computer acts not as a warehouse manager, but as a co-thinker.